my name is Mark Carroll. I'm the CEO of Montana Instruments. I took over in that role the end of 2020. And I'm going to just walk through a little bit about our contribution, our continuing role in the quantum ecosystem. It ends up that, you know, we've actually been serving the quantum industry for about 12 years. This is a list of some of our customers that, as you walk down the hallway to our production area, we like to recognize and get very personal with the principal investigators. We are, you know, something that we've been involved in this since it is a very complex science, and we have gone to great lengths to make the people who are challenging the state of the art in quantum make their jobs much easier by simplifying their experience, so that cryogenics is not the constraint, right? You just want to get to temperature and start taking data, because that's where the physics gets interesting. And we're an American company, obviously, and so our involvement in the QED-C since it was first formed has been very interesting to all of us here at Montana Instruments. We want to see America win this. We play primarily at 3.5 Kelvin, 1.5 Kelvin. We are involved in applications such as photonics, ion trapping, NV diamond centers, and also education kits. And so we get quite a bit of interest from, say, the next level universities that have teaching labs, and they like to buy equipment from us. So that's where it all starts. And we hope to be part of the educating of the quantum workforce. But further to that, we are not primarily focused on custom systems or integrating the exotic systems. We're focused on delivering standard products, and we have a product portfolio that offers good products, better products, and best products. And there are occasions where we'll step outside of that standard product offering, and those would be where we're getting designed into a quantum computer, as we are, and we get some volume, we get a blanket order with that. In addition, we also do OEM projects where we get multiples of offline quantum material characterization systems. And we've also done some very specific designs to support quantum sensors or atomic clocks. This is a little bit of our standard product offering. So kind of going from left to right, got CryoCore, our 50 millimeter chamber, our 100 millimeter chamber, or 200 millimeter chamber. CryoCore is focused on the education side of things. We hope to be participating even with community colleges and getting curricula up and running to educate folks who can be technicians or integrators within the quantum workforce. As you move up in chamber size, obviously you can put in more equipment in there. You can put in motion, you can put in cryo-optics, you can start to get into magnetics. And where do we differentiate it? So we have an ultra stable thermal sample mount, and we have best in class vibration stability. We have high NA cryogenics. And we've wrapped this all together with basically push button simple software to run your experiment. So we try to remove the constraint of cryogenics and make it just like a push button type thing to get to temperature, hold temperature stably and not introduce vibrations into the experiment, and so that you get your data that much quicker. A little bit about, some of the custom exotic systems. As I mentioned, we are designed into quantum computers, quantum networking, as well as sensing, that being atomic clocks. So a couple examples here of some of the complexity. But again, we really take those projects on where there's volume. So that's a little bit different than a lot of cryogenic companies. And what are we looking for? What we're looking for today is really, anybody who would want to partner in a financial sense. We're a small company in Montana, takes capital to grow. We have more resources and capability than the capital that we have today. And so we're looking for investors or partners. And please check us out at montanainstruments.com.
So Montana Instruments is focused on, bringing simple user interface and operation of these closed cycle cryostats, right? And also what I understand is you're heavily emphasized on deploying modern manufacturing techniques, right? And so as cryotech continues to enable leading quantum technologies, can you comment a bit more on the need for this, including your background in manufacturing? Because you say you're a small company, but you have a tremendous background in modernized manufacturing, right?
Yeah, no, thank you. Yeah, certainly we are going through a transformation. A lot of cryogenics has grown up, understandably so, as sort of configuring systems to a physicist's requirements, because they kind of don't know what they need, right? So it evolves throughout the project. We've been around this enough that there are high occurrence of the same requirements. And so we did an extensive study of that and said, okay, if we deliver this system to 80% of the customers in this application, they're almost exactly the same. So when we can identify that configuration, now we start to build world-class manufacturing around that. So we'll build a work cell around that, and we have enterprise requirements planning around that. So we're buying to a forecast rather than buying to a unique point design, which typically has a lead time of 16 weeks, right? So now our lead times are down even 4 to 6 weeks, because we're not starting the clock at PO. We already have all the inventory. We have sub-assemblies built up. And so we're just bringing those sub-assemblies together, doing the final integration and test. And so that's really exciting to see that happen in cryogenics for the first time. And so we believe we're creating really the first product company within cryogenics.
Great. And so with that, so you've got your CryoCore for universities, you said, and community colleges, and then you were saying that, your 50 millimeter, 100 and 200 millimeter system. What can you comment on where you're going from here?
Well, we do get pushed on the custom side, for OEMs, and typically they want higher vacuum. They want, more cooling power. They want faster cool downs, of course, because ultimately, quantum computer, you want to get to temperature, you want to stay there for years. So that's a little bit different. However, even if you have to do some preventative maintenance, they don't want to take down a computer for a week, right? Between warm it back up, change out parts, cool it back down, that still has to be fairly quick. So cooling power is important, but I would say primarily it's vacuum and vibration. So we're doing a lot of work there to satisfy our customers, our demanding customers, which are quite different than research customers, right? Research customers are okay with a 16-week lead time.
Right.
OEM customers are not. And so that's a little more of a Silicon Valley type approach that you and I know quite well.
That's also because those customers have customers that don't like that either, right?
Yeah. So you're signing
Exactly
contracts that have penalties for downtime and things like that.
Yeah.
So that's a totally different business architecture, right? You have to be extremely agile, and you have to also start to talk about things like mean time between failure. Which, physicists who are going to be there for 7 years anyway, they're okay with it going down, and you can send out a technician in a few weeks. But that's not the case with, semiconductor capital equipment model, where you have to have people there immediately, and you have to have spare parts on the floor, things like that. So, we're now growing up in the new paradigm here, which is going to be more similar to semiconductor capital equipment.
Yep. Thank you, Mark.